The air is warm and thick with the smell of damp earth, wet ferns, and the sweet resinous scent of distant conifers. You are standing on the edge of a vast floodplain, a seemingly endless savanna of green that stretches to a hazy purple horizon. The ground is soft under your feet, and the silence is a living thing, punctuated by the buzz of insects the size of small birds and the rustle of unseen creatures in the dense undergrowth of cycads and horsetails. Above, the sun hangs in a sky of the deepest blue, its heat tempered by high, wispy clouds. It's a world that feels both deeply alien and strangely familiar. Ever wonder what it truly felt like to stand in the shadow of a living giant, to feel the air itself vibrate with its presence? We'd love to know where you're watching from today, and which incredible prehistoric creature has captured your imagination. Let us know in the comments below. Now, let's journey back in time and uncover the story of a lost world. You are in the heart of the Late Jurassic period, around 154 million years ago. The ground you're standing on will one day be Western North America, part of a famous fossil treasure trove called the Morrison Formation. But right now, it is a world in its prime. The supercontinent of Pangaea has fractured, and a shallow sea is beginning to divide this landmass, creating a climate that is monsoonal. For part of the year, it is arid and dry. But you are here in the wet season. The rivers have overflowed their banks, creating a lush, sprawling wetland that is an absolute paradise for herbivores. Yet, for all the life teeming in the ferns at your feet, your gaze is drawn upward, toward the gallery forests that line the great river in the distance. The trees there are immense, towering conifers and tree ferns that reach for the sky. Then you notice something impossible. The tops of those colossal trees are moving, not swaying in the wind, but dipping and parting, as if something is gently pushing them aside. You hear a sound, a deep resonant rumble that you feel in your chest more than you hear with your ears. It's the sound of a living mountain on the move. And then it appears, a head and then a neck, rising serenely above the canopy. It moves with a slow, deliberate grace, a living watchtower surveying its kingdom. It is taller than any tree, a creature built on a scale that defies belief. It isn't just big, it's vertically immense, a biological skyscraper browsing on leaves that no other creature could ever hope to reach. This is Brachiosaurus, and you have just stepped into the land of the true giants. The colossal creature takes another slow, deliberate step, emerging from the cover of the towering conifers and into the open floodplain. Now you can see its full form, and you realize it's built unlike any other animal you could ever imagine. Its body isn't a long, level bridge like some of its sauropod relatives. Instead, its back slopes dramatically upwards from its hips to its colossal shoulders, giving it a posture that is permanently raised, like a giraffe of impossible proportions. This unique architecture is the very key to its identity, hidden in the name scientists would one day give it, Brachiosaurus. It translates to arm lizard, a name that sounds simple, almost mundane, until you understand why it was chosen. The paleontologists who first studied its bones were stunned by the sheer size of its humerus, its upper arm bone. It was longer than any femur they had ever seen. You are looking at an animal whose front legs are significantly longer and more powerful than its hind legs. This is the feature that sets it apart, the evolutionary masterstroke that defined its existence. Its entire skeleton is engineered to lift its front half, and therefore the base of its neck, higher into the sky than any of its contemporaries. Its shoulders are the peak of a mountain of flesh and bone, and from that peak, the neck begins its final, incredible ascent. You can see the immense power in its deep barrel-shaped chest, a cavity large enough to hold lungs the size of small hot air balloons, and a heart that must have been a muscular engine of incredible strength. Its tail, unlike the long, whip-cracking tails of its cousins, is shorter, held high off the ground, simply to act as a counterbalance. Its purpose isn't defense, but stability for the incredible structure at the front. Your eyes follow the slope of its back up to its magnificent head, which seems almost small for such a gargantuan body. It has a distinctive, high-arched skull with enormous nasal openings right above its eyes, giving its face a curious, almost noble expression. For years, popular culture would mistakenly place its nostrils at the very top of this bony dome, like a snorkel. But the reality is even more interesting, suggesting a complex system of soft tissues and resonating chambers. This wasn't just a giant. It was a specialized, beautifully adapted creature, an arm lizard whose very bones tell the story of a life spent reaching for the sun. That incredible neck, held at a steep angle, is a masterpiece of biological engineering. You watch as the Brachiosaurus lifts its head even higher, and you begin to ponder the immense physiological challenges at play. How does a living creature support a 30-foot-long neck and, even more astoundingly, pump blood all the way up to its brain? The answer begins in the bones themselves. Were you to hold a vertebra from that neck, you'd be shocked. For its size, it would be impossibly light. The secret is that the bone is not solid. It is hollowed out, filled with a complex network of air sacs, a feature it shares with modern birds. These sacs, connected directly to its enormous lungs, acted like an internal scaffolding, dramatically reducing the neck's weight without compromising its strength. It's the same principle as the lightweight honeycombed structures used in aerospace engineering. The neck was held aloft not just by muscle, but by a massive ligament like a structural cable running along the top of the spine, allowing it to maintain its posture with surprising efficiency. But the true miracle of the Brachiosaurus is hidden deep within its chest. Pumping blood against gravity up 3 stories to the brain is an extraordinary problem. The solution must have been a heart of unimaginable power, a muscular engine perhaps weighing over 400 pounds. To get the job done, this creature would have needed a blood pressure at least 3 to 4 times higher than your own, a pressure that would be instantly fatal for a human. Its arteries would have been enormous, reinforced with thick, muscular walls to contain the incredible force, and likely lined with a series of one-way valves, a clever plumbing system to prevent the blood from flowing backward between heartbeats. This high-performance cardiovascular system tells us something profound about this animal's entire physiology. A slow, sluggish, cold-blooded metabolism simply could not power such an energetic system. The evidence points to an animal with a much higher metabolic rate, a warm-blooded giant that generated its own body heat. You can almost feel the energy radiating from it. Hear the deep, rhythmic sound of its breathing, like a blacksmith's bellows, as its massive lungs process hundreds of liters of air with every breath. This wasn't a languid, slow-motion reptile. It was a dynamic, high-energy marvel, a living furnace that had to consume a colossal amount of fuel to power the biological machinery of its gigantic body. To fuel that high-energy, internal furnace, the Brachiosaurus had to be a master of consumption, an eating machine on a truly epic scale. And now, you see that machine in action. The giant lowers its head slightly, its gaze fixed on the tender new growth at the very top of a towering conifer. Its strategy is one of pure efficiency, a perfect marriage of its unique anatomy and its environment. It is a high-canopy specialist, harvesting a food source utterly beyond the reach of any other contemporary herbivore. The smaller sauropods, the armored stegosaurs, They are all confined to the ferns and low-growing cycads. But the world 30, 40, even 50 feet in the air belongs exclusively to Brachiosaurus. As its head gets closer to the branches, you can imagine its mouth. A close look at its skull in a museum would reveal a surprising detail. Its teeth were not the complex grinding batteries of later plant eaters. They were simple, peg-like, or chisel-shaped implements, beautifully suited for a single task. This animal did not chew. Chewing would require heavy jaw muscles and a large, heavy head, an impossible burden at the end of such a long neck. Instead, it used a far more elegant technique. You watch as it clamps its jaws around a lush branch, and then, with a powerful but graceful pull of its neck, it simply strips the foliage away. The leaves, soft shoots, and pine needles are raked into its mouth and swallowed whole. That unchewed mass of tough plant matter begins a long journey down its immense esophagus, destined for a specialized digestive system. Deep within its cavernous gut, a muscular gizzard would have taken over the job of the teeth. Like many modern birds, it's almost certain that Brachiosaurus swallowed stones, known as gastroliths. These stomach stones would have been churned together with the plant-filled slurry, acting as an internal mill, grinding the tough cellulose into a digestible pulp. To power its high metabolism, this 50-ton giant likely needed to consume over 400 pounds of vegetation every single day. Its life was a continuous, quiet quest for food, a living harvester methodically moving through the Jurassic forests, gardening the treetops. As your eyes adjust to the sheer scale of the creature before you, the scene widens, and you realize this gentle giant is not alone. Further out on the floodplain, several more of these living towers are moving with the same unhurried, ponderous grace. You are witnessing a family group, a small herd of Brachiosaurus. There's a colossal bull, his skin creased and scarred from a long life, flanked by two slightly smaller females and a younger animal. An adolescent that is already the size of a house, but lacks the immense bulk of the adults. The idea of these titans living together isn't just speculation. It is a story written in stone. Fossil trackways discovered around the world show the footprints of multiple sauropods, all walking in the same direction, their paths overlapping. It's the clearest evidence you could ask for. These were social animals. Living in a herd provided obvious advantages. There was safety in numbers, as the presence of several vigilant skyscraper-high heads made a surprise attack from a predator nearly impossible. It also allowed them to share information about the best feeding grounds, a crucial benefit in their constant search for the thousands of pounds of food each one needed. You watch the young one stay close to its mother, learning the vital skills of survival in this Jurassic world. Its very existence raises one of the most incredible questions of all. How does an animal get this big? The answer is that it grew at a pace that seems almost unbelievable. From a hatchling no bigger than a goose, a young Brachiosaurus would have packed on pounds at an astonishing rate, reaching its colossal adult size in just a few decades. This explosive growth is one of the strongest arguments for them having a high-revving, warm-blooded metabolism, more like a bird than a reptile. A cold-blooded animal simply couldn't sustain that level of rapid development. This was a life lived in fast-forward, a biological imperative to get big, fast. Size was their ultimate defense, and their entire physiology was geared towards achieving it as quickly as possible. The herd moves together, a slow-motion river of life, their shared purpose a silent, powerful bond in a world of giants. The majestic, slow-motion procession of the herd seems to create a bubble of tranquility, a zone of untouchable peace. But this Jurassic world is not a paradise. For every giant herbivore, there is a giant hunter, and the two are locked in a timeless evolutionary arms race. A flash of movement in the shade of a distant fern grove betrays the illusion of safety. You see a predator emerge, moving with a confident, athletic gait. It's an Allosaurus, the lion of the Jurassic, a 30-foot-long carnivore built for the hunt. Its massive head is armed with a mouthful of blade-like, serrated teeth, and its powerful three-fingered hands are tipped with vicious, curving claws. It is the apex predator of this environment, a killing machine perfected by millions of years of evolution. And yet, as it steps into the open, it seems almost comically small. The predator's head would barely reach the knee of the adult Brachiosaurus it is watching with an unnerving intensity. This is the ultimate challenge for a hunter. A direct assault on a healthy, full-grown adult is simply unthinkable. It would be like a wolf trying to take down a battleship. The sheer size of the Brachiosaurus is its primary weapon. A single, well-placed kick from one of its pillar-like legs or a crushing slam of its multi-ton body would be instantly fatal. The adult brachiosaurs are walking fortresses, mountains of flesh and bone that have, for the most part, grown beyond the reach of predation. So, the Allosaurus waits. Its strategy is not one of brute force, but of patience and opportunism. It shadows the herd, its sharp eyes scanning for any sign of weakness. Is there an individual lagging behind? An old one showing signs of illness? Or the ultimate prize, a juvenile that can be momentarily separated from the protection of the adults? The great herbivores are aware of the threat. The deep, rumbling calls become more frequent, and the adults subtly shift their positions, forming a living, impenetrable wall around the younger members of the herd. They don't panic or run. Their defense is their overwhelming presence. The Allosaurus, seeing the solid, vigilant defense and the sheer impossibility of its task, eventually melts back into the tree line. For now, the giants have won. Their place at the top of the food chain, secured not by teeth or claws, but by the simple, undeniable power of being big. The Jurassic sun sets, and the herd of giants fades into the twilight, their thunderous footsteps dissolving into a silence that will last for 154 million years. The lush floodplains dry up, the shallow seas retreat, and mountains rise and fall, burying the world of the armed lizard deep beneath layers of rock and time. The wind blows across the same patch of earth, but it is now a dry, rugged landscape of canyons and mesas in the American West. It is the dawn of the 20th century, and the ghosts of the Jurassic are beginning to stir. It was in these badlands that paleontologists, hunting for the remains of a lost world, stumbled upon something extraordinary. A bone, weathering out of a hillside, larger than any they had ever seen. The excavation that followed was a monumental task, carefully chipping away the stone tomb that had held the giant captive for an eternity. As the skeleton slowly emerged, the team uncovered a spine of colossal vertebrae, massive ribs, and then the bone that would define the creature. An upper arm bone, a humerus that was over 6 feet long. They had found the arm lizard, and the world of paleontology would never be the same. When its skeleton was first mounted for display, it was a revelation. For decades, sauropods had been imagined as sluggish, swamp-dwelling behemoths dragging their tails through the muck. But Brachiosaurus, with its powerful pillar-like front legs and steeply angled back, shattered that image. Its very anatomy was proof of an active terrestrial life. It was a key piece of evidence in a scientific revolution that reimagined dinosaurs as the dynamic, successful animals they truly were. This new, majestic posture was immortalized in museums, its head soaring towards the ceiling, inspiring awe in generations of visitors. That sense of wonder was captured perfectly in its modern film debut, where it was presented not as a monster, but as a graceful, gentle giant. The first dinosaur to truly captivate an audience with its majesty rather than its terror. From a living, breathing animal to a legacy in stone, Brachiosaurus corrected our vision of the past, proving that the reality of these creatures was far more incredible than we had ever dared to imagine. And so, our journey ends. We leave the late Jurassic plains, and the silence returns. A profound quiet that holds the echoes of thunderous footsteps and the rustle of colossal life in the ancient forests. The bones of the armed lizard, now resting in museums, are our one tangible link to this lost world. A world that operated on a scale almost beyond our comprehension. They are a humbling reminder that our own time on this planet is just a brief chapter in its immense and epic story. The tale of Brachiosaurus is not just about a single animal, but about the enduring power of discovery to resurrect lost worlds and reshape our understanding of the grand, sprawling story of life on Earth. And it leaves us with the quiet, persistent wonder of what other giants, what other lost stories still lie waiting to be unearthed from beneath our very feet.